disturbing a reaction at equilibrium. So we've got the equilibrium. What happens when we throw some extra stuff in there, when we disturb or mess up the equilibrium? The equilibrium is going to fight back. It's going to try to undo what we did to it. This is called Le Châtelier's principle. When a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes the disturbance. I can relate to this because I'm a person who does not like change unless it's my idea, right? I don't like change being imposed on me. They're cutting down some trees along the road that I take when I drive to work, and I don't like that. If I had my way, I'd put those trees back. Just leave it alone. I liked it the way it was. So when you mess with an equilibrium, it's going to fight back against that. So think of it as an ornery person who doesn't want to change. So we're going to go back to Fantasyland here. Here we've got Narnia and Middle Earth. So an equilibrium was established. We've got people moving back and forth because people are always unhappy with where they are, right? But the populations of Narnia and Middle Earth are constant. There's just people moving back and forth at the same rate. What if we disturb the population of Middle Earth by adding a bunch of people to it? How did those people get there? I think a spaceship came and dropped them in. That's what it kind of looks like, right? Here's the spaceship with the people in it and deposit them in Middle Earth. However they got there, all of a sudden there's a whole bunch more people in Middle Earth. What's that going to do to the relative rates of people moving back and forth? It's going to increase the number of people that are moving to Narnia because Middle Earth is suddenly really crowded. And now Narnia is looking better. So it was equal with our pictogram here. We've got 3 people moving to Middle Earth and 3 people moving to Narnia. After we've added a whole bunch of people here, now we're going to have 4 people moving to Narnia and 2 people moving back because it's crowded over here. So this is going to cause a shift in the population of getting rid of some of those people that came into Middle Earth from the spaceship. I mean, why not have a spaceship, right? So we disturb the equilibrium by putting people in on this side. The equilibrium shifts to undo that. It says, oh, you're going to put a bunch of people in here? Well, I'm going to move it so that I get rid of some of those people. So it'll shift and move those people to the other side. Does that make sense? What if you took a bunch of people out? What if instead of putting people into Middle Earth, maybe the spaceship came and kidnapped a bunch of them, took them off to do experiments on them? Or maybe they died of cholera or something, who knows? What if a whole bunch of people died? Yeah, then Narnia, the people in Narnia are like, ooh, there's all that space over there, I'm going over there, right? So if you take things away, the equilibrium shifts to replace them. You put more in, it shifts to get rid of them. It's ornery, right? It fights back against change. Here we have an equilibrium. If we add product, if we add NO2, the reaction will shift away from what we're adding. The reverse reaction will increase. If this concentration increases, there's going to be more collisions, right? And so the rate of the reverse reaction will increase. And then eventually they'll settle down and a new equilibrium will be established. The equilibrium constant will remain constant, but the concentrations will have changed. So it shifts to the left, bringing this back down closer to what it was before. Here we can see in a picture, we've got our equilibrium set up here, and we're going to add a bunch of product. Well, the product is going to cause the reverse reaction to increase, and those things are going to react so that we can get rid of some of them. Does that make sense? If we add reactant, we add some of this. The equilibrium says, I don't like that. You're changing things. I'm going to shift over here to undo what you did to me. So I'm going to shift to the right to decrease that concentration that was added. You're adding more reactant will cause the reaction to shift away from what you're adding. So if a system's at equilibrium, if you increase the concentration of a reactant, it's going to cause the reaction to shift in the direction of the products. If you increase one of the products, the equilibrium will shift away from that into the direction of the reactants. Does that make sense? So these are the sorts of questions we need to be able to answer. So here's a reaction at equilibrium. What's the effect of adding more Br2? Your choices are shift right, shift left, or no effect. Yeah, if we add Br2, the equilibrium says, hey, I didn't want all that Br2. I'm going to shift over here and get rid of some of it. So this will cause a shift to the left. What if we add more BrNO? It'll shift to the right. You're adding reactant. It's going to shift away from what you're adding. It'll shift to the right. What if we remove some Br2? We take some of this away. It'll shift to the right. It's like, hey, I liked that. I want it back. Well, I'm going to shift over here and make some more to replace what you took away. That make sense?